Alright, so we left off where the distance of this purple line. We need to minimize this distance. So if we keep going from here, we take the distance and we need to minimize it. So we set the derivative equal to 0. So to find the minimum value of x, and when we take the derivative, you have the bottom, which is just the root on the bottom. So what will happen on the bottom is when we take the derivative of the top, remember that anything to the power of half is equal to 1/2 of the item under the derivative. So don't forget that there would be a 2 at the bottom. So the 1/2 is here, and the root would go to the bottom, which is what we have here. What goes in the numerator is the derivative of what's inside the root sign, which will be the following. So this is the derivative of the number underneath the root sign. Take the derivative of the first one, which is 2, times the derivative of the inside, times the outside to the power of 1, plus the derivative of the inside with 2 times 60, which is 120, and then you're left with 60x to the power of 1. You expand it, collect like terms. In fact, what happened here is I took out a common factor of 100, and I'm left with these values on the inside. And when we do this, we end up with a value of 50 times 122x minus 75. Remember, the 100 gets divided by 2 if you're wondering. And this is the answer that we will get. We will get 75 over 122. Well, what does that mean? This is the number of minutes that you will have as a result. All right, let's see what we can do with this. So what this means is that if we convert this to minutes, this is in hours right now, we need to convert it to minutes. You get about 37 minutes because the question says to the nearest minute. So therefore, at 137, they arrive at 2:30, so 1:37, both p.m., both Prithvi and Adam are the closest to each other, and you can finish the therefore statement. All right, on to the next question. Example 5. Zamar plans to use the annual talent show to raise money for a charity. Last year, tickets sold for $11 each and 400 people attended. Zamar determined that by raising the price by $1, the number attending would decrease by 20 people. What ticket price would maximize revenue? So what ticket price should Zamar set in order to raise the most amount of money for the charity? Well, the thing that's changing here, so the variable, the idea that something's changing, and you learned these type of formulas in both grade 10 and in grade 11, we let x represent the number of $1 increases or raises. $1 increases. So the revenue function is equal to, as you know, to gather revenue, you must have a ticket price and multiply it by the number of tickets. So we have a ticket price of 11 plus 1x times the number of tickets sold, which will be 400 tickets, and you lose 20 tickets for every $1 you increase the price. So 11 plus $1 increases, we don't know how many increases that will be, times the number of tickets sold, and every time you increase it, well, you decrease the number of tickets that you'll sell. Increase price, decrease tickets. In decrease price, you increase tickets. So there's always going to be a yin and a yang with that. All right. Now, revenue. 11 plus 1x times 400 minus 20x will result in an expanded equation, which you then take the derivative and set that equal to 0. When you take the derivative, you get this value, and you set the derivative equal to 0, which will result in 4.5. Well, what does this mean? Well, the ticket price is going to be 11 plus 1 times 4.5. Could you have 4.5 raises? Well, folks, we're talking about $1 raises, so of course you could, because you could raise it by $4.50. When you raise it by $4.50, you get $15.50. So therefore, the ticket price should be $15.50 to maximize revenue. All right, down to the last question. A right circular cylinder has to be designed to fit inside a sphere of 4-meter diameter so that each of the top and bottom touches the sphere along its complete circular edge. What are the dimensions of the cylinder of maximum volume, and what is the maximum volume? So that's the question. So you have a sphere here, and then with that sphere, you're going to have a right circular cylinder. So that if you were to look at it face on, it looks like you have basically a rectangle built or a square built inside a sphere. So that each edge touches the sphere, so that when we go across the edge of it, you'll see here that covers the diameter. What does that mean in terms of what we need to do? Well, the volume of a cylinder is pi r squared h. The surface area, what we're looking at here is pi r squared h is the volume of this cylinder. Because it's a cylinder, there's a circle at the top, and what you do is you take the area of a circle and multiply it by the stretch, and that's how you calculate the volume of a cylinder. Now, let's look at how I was able to develop this. Well, here is the height. We agree that that's the height. Over here is 2 times the radius, and that must, if I take the Pythagorean Theorem says that if I we use Pythagorean Theorem to find this equation, or an equation that represents this information. This 4 here represents the diameter of the sphere, which is given in the question. So we have 2r squared plus h squared is equal to 16. That's 4 squared. Again, we're using Pythagorean Theorem to get this value. So what does that mean for us? Well, r squared is equal to 16 minus h squared all over 2. Why am I isolating for r squared? Well, we need to isolate for one of these values. Note here, we have r squared in the equation. So it makes sense that we want to substitute the r squared into the volume formula. And we get volume is equal to 16 minus h squared all over 2 times h. What does that mean? Well, we've now substituted a different value in here so that we could find the derivative. We set the derivative equal to 0, and you can use product rule or you could expand it. Ultimately, what you end up with is this. Why is that the case, folks? Well, I want you to pay attention how I got these values. So, in terms of the first one, I need to take the derivative. Okay, we're going to try that again. So we're looking back at the volume. Volume is equal to 16 minus h squared over 2 times h. Again, it's... Alright, let's go back. So we have the volume over here is equal to 16 minus h squared over 2 times h times pi, folks. We forgot the little pi there. So let's continue to the other side. All right, so we have the volume is equal to that times pi, and then we can expand it, and I'm leaving pi on the outside. When we take the derivative, the pi is just a constant multiple. And when we know that the rules for derivatives, a constant multiple doesn't change the derivative on the inside. So we can take the derivative of the ones inside the bracket, multiply by pi, but then when we set that derivative equal to 0, we can divide out pi so that we're only focusing of when the information inside the bracket is equal to 0. Well, we find out, lo and behold, that h has to equal plus or minus 4 root 3 over 3. Well, it can't be minus, folks, because we're talking about the height of something. So we can continue with just the positive value to find out that what our r squared value is, which turns out to be our r value, which is 4 root 3 over 3, because the question asks for the dimensions, and it asks us what the volume will be. Well, the volume will be pi times the height times the radius, so squared. And when we calculate that value, we find out that the value of the volume is going to be 64 root 3 over 9 units squared. And if we look back to the question, it talks about 4 meters in diameter. So when we have that final value, that's going to be in meters squared, folks. So we can now take our therefore statement right here, our therefore, and say, therefore, the maximum volume will be 64 root 3 over 9 pi meters squared. Or you could calculate the approximate value if it says rounded to the nearest value. This is the exact value, so it's not that hard to type it in to find the decimal value. And the dimensions are as follows. Again, the dimensions I give you are the exact values, and you could go ahead and plug it into your calculator to find the decimal values. All right, that's the end of this unit, folks. Take care. Good luck on your test.